Now Aiden, like a good mathematician, wants to make sure that he never divides by 0. So what real numbers can he replace for x in the expression 3x plus 2 over 5x minus 3? So he never wants to divide by 0. So in the denominator here we can see this 5x minus 3, and we want to make sure that he never divides by 0. So as part of our solution, we're going to take the expression 5x minus 3. This is the part in the denominator, and we're going to make sure that this never equals 0. Add 3 to both sides so that 5x never equals 3, and then divide both sides by 5, and you can see that x must never be 3/5. So his solution set is all real numbers except for 3/5. If we were to represent this on a number line, it would look something like a number line. We have the number 3/5, which is located right here, and it would be everything but that number. So I would normally represent that maybe with an open circle, and then shading all the way left and all the way to the right. So how would we represent this in an interval notation? So interval notation means to include all of the numbers that can possibly work for this solution. So notice that we can go all the way to the left as far as we possibly want. So that's all the way up to the concept of negative infinity, not including negative infinity, because remember, that's not a number. And then we can shade all the way up until, but not quite including, the number 3/5. So that's kind of the left half of what's going on here, all the way up to, from negative infinity up to 3/5, but not including 3/5. But we can also include numbers to the right, right? We can include numbers from 3/5, again not including 3/5, but all the way up to the far right end, which is infinity. So we have the numbers from negative infinity to 3/5, and then the numbers from 3/5 until infinity. So this interval would be negative infinity to 3/5 unioned with 3/5 to infinity. And this would be the final answer for Aiden's question in interval notation.